Interval notation is the name for a specialized notation that we use to describe the solution sets of inequalities. The solution sets of inequalities are called intervals. They're special subsets of the real numbers. And the thing that makes them special is that we can think of them as either line segments or arrays in the number line. So either the real numbers between two endpoints, or the real numbers to the left of an endpoint or to the right of an endpoint. We can think of what we're writing in interval notation as a shorthand for what we see in the graph. So here we have a graph with an open dot at -3 to the left, an open dot at 0 to the right. In interval notation, we write -3, 0 in, I'm going to call these round brackets when we're talking about interval notation. They're parentheses. They use the same key on your keyboard as parentheses. But in interval notation, I want to think of them as round brackets. Here we have an interval with -3 with a closed dot on the left, -1 with an open dot on the right. In interval notation, we write -3, 1 with a square bracket on the left and a round bracket on the right. So this is a square bracket, round bracket. Here we have an interval with an empty dot at 0, a filled dot at 2. We have 0, 2 with a round bracket at 0 and a square bracket at 2. Here we have filled in dots at 2 and 4. We have square brackets around 2, 4. Here we extend indefinitely to the left, and then we have an open dot at 2. And we have this new symbol here. What's this symbol? This symbol is called infinity. And in this case, we have an infinity with a negative sign in front of it. So -infinity, 2, round bracket on the left, round bracket on the right. Open dot at -1, extending indefinitely to the right, -1, infinity, round bracket on the left, round bracket on the right. Filled in dot at 4 gives us a square bracket next to the 4. Filled in dot at 0 gives us a square bracket next to the 0. So what's going on here? In interval notation, we have a number on the left and a number on the right. The left number in bracket describe the left end of the graph. The right number in bracket describe the right end of the graph. If the left end is an open dotted a number, we have a round bracket and a number. If the left end is a closed dotted a number, we have a square bracket and a number. If the left end just continues forever, we have a round bracket and -infinity. Similarly on the right, if the right end is an open dotted a number, we have the number followed by a round bracket. Closed dotted a number, we have the number followed by a square bracket. Continuing forever to the right, we have infinity followed by a round bracket. One of the things we can think of is the round bracket means that the number is not in the interval. The square bracket means that the number is in the interval. And then those infinity symbols, -infinity and infinity, those aren't numbers. They can't be in the interval. Only numbers can be in an interval. So the -infinity and infinity always get a round bracket. It's helpful when you're writing interval notation to either actually draw the graph or at least imagine the graph. So we've got some inequalities here. We're going to represent their solution sets in interval notation, but first we're going to sketch a graph. When you're writing interval notation, you can actually write this if you find it helpful, or at least imagine it. So x is less than or equal to 7. The only number we're interested in is 7. X is allowed to equal 7, so we have a filled in dot there. And then the numbers less than 7 live over here. So in interval notation, we have no left endpoint. So we'll start with negative infinity with a round bracket. The right endpoint is 7 with a closed dot. So the right end is 7 with a square bracket. X is greater than 5. The number we're interested in is 5. We'll have an open dot there. The numbers greater than 5 live over here. So in interval notation, our left end is 5 with an open dot. So we have 5 with a round bracket. And then we continue forever to the right. So our right end will write positive infinity with a round bracket. Okay. Negative 3 is less than or equal to x is less than or equal to negative 2. So we're going from left to right with less than signs. We're interested in negative 3 and negative 2. X is allowed to equal negative 3, so we have a filled in dot there. X is allowed to equal negative 2, so we have a filled in dot there. And then we fill in between. Our left end, we have the number negative 3 with a filled in dot, so a square bracket. And then our right end, we have the number negative 2 with a filled in dot, so a square bracket. One more. 6 is greater than x is greater than or equal to negative 5. So we've got greater than symbols. We're going from right to left. All right, we have 6 over here. We have negative 5 over here. Of course, when we draw a number line, our number line has to be in order from least to greatest. So negative 5, x is allowed to equal negative 5, so we have a filled in dot there. X is not allowed to equal 6, so we have an open dot there. X is between them. Left end, we have negative 5 with a square bracket. Right end, we have 6 with a round bracket. Now, there's something a little bit tricky about interval notation. We can write negative 2, 1 to represent the interval from negative 2 to 1 on the number line, or we can use it to represent a point in the plane, right, with x coordinate negative 2 and y coordinate 1. When we see that notation, open parenthesis or round bracket, negative 2 comma 1, close parenthesis or round bracket, how do we know whether it represents an interval or a point? Unfortunately, we have to know from context. Are we expecting to see a point? Then that's a point. Are we expecting to see a set? Then that's an interval. We have to know from context what kind of thing we're expecting to see before we can interpret that bit of notation. Fortunately, it usually is clear from the context what that represents if we understand what's going on in whatever problem we're currently considering.